In this course, you will learn to build computer vision projects with Arduino. The course combines computer vision, deep learning, and Arduino. Yılmaz ALACA will teach you to build two projects. The first project will control an LCD display using your facial movements, leveraging deep learning and powerful tools like MediaPipe to detect and interpret facial features. In the second project, you will learn to control a robotic arm using computer vision. The course covers topics like serial communication between Python and Arduino, face detection using landmarks, and practical applications with LCD displays and servo motors. You'll gain skills in image processing with OpenCV. So get ready to explore advanced computer vision applications.
Nowadays, computer vision and deep learning topics are very popular. Would you consider making an advanced project by taking advantage of these issues? My name is Yılmaz ALACA and welcome to the introduction video of my advanced computer vision project with Arduino course. With the course, we will detect our facial expressions and automatically print our facial expressions on our LCD screen according to our expressions. If you want to do advanced computer vision project, this course is for you. I can't wait to see you among us already. Let's get started without wasting any time. Yes, my dear friend, in this lesson we will have information about the materials we will use in our course. First of all, the first material we will use is Arduino Uno. We will provide LCD display control according to the signals coming with Arduino Uno. Our second material is an I2C supported LCD display. With this screen, we will print out on our LCD screen. The other material we will use is the webcam. With the help of the webcam, we will learn our facial expressions instantly and add meaning to what we have learned. And of course, a cable is required to connect our Arduino Uno board to the computer. Yes, my dear friend, this is how our materials are in general. So now, let's start our course without wasting time and realize our advanced project. In this lesson, we will see how we can install Python to our computer. First, let's open Google and write Python. And let's press enter. As you can see, Python's official site is available. Now let's open it. And here, as you can see, there is a download section. Let's open it. And here, Python version 3.9.7 is available. Let's download Python. I click hide and here, as you can see, it's downloaded. Let's open it. Since I have installed it before, I encountered a screen like this. For this reason, I will choose customized installation. And here, as you can see, optional features is here and I will click next. And here, as you can see, there is advanced options. I will leave it in a default format, so let's hit the install button directly. I click install. As you can see, Python is installing. Let's continue when we are done. As you can see, we have successfully installed Python. Let's click close. Now, let's write Python in the search section of Windows. I click search button and I write here Python. I click this app, Python 3.9. I am choosing this. And here now let's write print. And open parentheses and close parentheses. And between parentheses, create double quotes. And between double quotes, I will write hello world. And press enter. As you can see, we have successfully installed Python. In this lesson, we have seen the Python installation. Let's continue with other lessons now. Hi, in this lesson you can have information about how we can install the PyCharm IDE. PyCharm IDE is an environment that allows us to write our Python codes easily. We will write and run codes in Python lessons throughout this IDE. So let's get started. First of all, let's type PyCharm into Google and press enter. I will write PyCharm here and I press enter. As you can see, it says download PyCharm here. Let's click this. And here it is available in paid and free version. We will use free version, so I am using community version because it's free. So let's click community download. I am choosing the community one. And I click hide and look, it started. Let's continue when it's done. Alright my friend, the downloading is over. Let's click this. And here is the setup screen as you can see. I click next. This is the destination folder. Whatever you want, you can use any destination folder. I will choose default. So I click next. So as you can see, there are some options. I will choose the create desktop shortcut and update path variable. So I click PyCharm Community Edition and also add bin folder to the path. And then I click next and I click install. It's installing. When it finished, we will continue. Yes my friend, the installation is complete. Now we need to restart our computer. I will choose the reboot manually, but you can restart your computer by selecting reboot now. So I click I want to manually reboot later. And I click finish. So let's reboot our computer. Alright my friend, I rebooted my PC and as you can see here, there is PyCharm IDE app and I click this. This is the user agreement. I confirm that and I click continue. And here as you can see, this is our PyCharm IDE screen. So let's learn PyCharm IDE. If I click new project button, the PyCharm IDE start a new project. Let's click this. And here as you can see, there is location section and this Python project 5 is our project name. If you want to rename your project name, you can change here. For example, I will change my project name. Let's write here hello. And as you can see, there is base interpreter. This is very important because we will run our Python code and this is the part that will run our code. If you want to use all Python versions, you can change here. But if we use Python 3.9, it will be fine for us. So I click Python 3.9.exe. And as you can see here, there is a create button in the lower right corner. Let's click this. So if I click this, my project will be creating. Yes my friend, as you can see, our project has been created. And here is our project name, which is hello. So let's continue. Let's click close and move to your project folder. And let's right click and move to new and move to Python file. And here we can create our own Python file if we follow these steps. Now let's name our Python file. For example, first project and press enter. And here as you can see, our Python file has been created. Now let's come here and write print and open parentheses and close parentheses and between parentheses write double quote and write here for example Yılmaz. So when we do something like this, we use the standard output function in Python. And if I press the right button of my mouse, and as you can see, here is the option to run it. If I select run first project, my Python file will run. Let's click this. And as you can see here, we run our first code. Yes, my dear friend, we have installed our PyCharm IDE in this lesson. Of course, these sections can be boring. However, we will have a lot of fun writing our project codes once we have the necessary setups done. Let's continue with our other installations now. Yes, in this lesson we will learn how to install our OpenCV module in PyCharm IDE. As you can see, there is a terminal section here. Let's select this. And now we have to write some codes to our terminal section. Let's write. I will write pip, put a space, and then we have to write install, put a space, and also we have to write OpenCV minus Python. And now let's press enter. As you can see here, we have successfully installed our OpenCV module. Now simply import in your Python program in which you want to use image processing functions. So let's check it. Move to your project folder and let's right click, move to new, and let's create a new Python file. And let's say here, for example, test, and press enter. And then we have to import OpenCV module. Let's write import, put a space, CV2. If we do like this, we can define our OpenCV module. And to check if OpenCV is correctly installed, let's check it, move to a new line, and let's write print function, open parentheses, and let's say cv2 dot underscores version. And also put underscores. And now let's run our code. As you can see here, we have successfully reached our OpenCV version. So the installation is successfully. Yes, we installed our OpenCV module in this lesson. Let's continue with our next lesson. Yes, my dear friends, in this lesson we will install our MediaPipe module. So why are we going to use this module? Because with this module we will reach the landmarks of our face and learn our gestures according to the coordinates of each of our facial lines. As you know, when we smile, our lip movements are at different points. Of course, this also applies in sad and normal situations. For this reason, we will perform these operations together with the MediaPipe module. So let's move on to the installation now. Let's open our PyCharm IDE and come to the terminal section. And let's write here pip, put a space, install MediaPipe. And also let's press enter. And as you can see here, we have successfully installed our MediaPipe module. So now let's continue with our next lesson. Yes, my dear friend, in this lesson we will have information about Arduino IDE installation. First of all, let's write Arduino to Google. So I will write here Arduino and also press enter. And now, as you can see, Arduino's official website is available. So let's click that now, which name is also arduino.cc. So let's click this. And as you can see here, there is a software section here. So let's click this. And as you can see, there is version 1.8.16 available. We will choose the this download option, Windows Win 7 and also newer, because we will learn the basic Arduino knowledge throughout Windows. And also, if you are using different operation system, you can also choose different download option for your operation system. Now let's come and download this. I will download Win 7 and newer. So let's click just download. And as you can see, the installation was started. Yes, the download is complete. Now let's come and open it. And as you can see, there is a license agreement. So let's click I agree. And also we will install all of these components. So let's click next. And here is the path specification. I will leave that as default. So I click install button. Yes, the installation process is complete, so let's click close. As you can see, the Arduino app is here. Now let's move on to our next lesson and learn the Arduino IDE interface. Yes, my dear friend, in this lesson we will learn about the interface of Arduino IDE. First of all, as you can see here, there is the void setup part. The codes of the Arduino board are written in C or C++. The structure that starts with void here is a function. The void setup section allows us to set up our Arduino codes. And here the codes run once. And the while loop part you see here is our function that repeats the given commands continuously. And here we will perform operations such as a motor control, lamp control. And also, as you can see here, there are parts that verify and upload. The verify here checks the code we write. If it is upload, it uploads the codes we wrote to our Arduino board. When we come to the tools tab, so as you can see here, click this. We learned the USB port to which our Arduino board is connected. As you can see here is the port section. Yes, my dear friend, this is our interface in general. Let's move on to our next lesson. Yes, my dear friends, in this section we will learn how we can control our LCD screen with Arduino. So let's get started. First, let's take a closer look at our LCD screen. This is an LCD screen that you have seen in my hand. Our LCD screen consists of 2 rows and 16 columns. Also, we need to use 4 different lines to code our LCD screen. 2 of these lines are power lines, that is the GND and 5V pins. The other 2 lines are the I2C line, signal pins on these lines. Normally, we have to do a lot of wiring, but thanks to the I2C module, this wiring is considerably reduced. The SDA pin allows us to transfer data, and also SCL is the clock rate. So the SCL pin allows us to transfer all data synchronously. Yes, my dear friend, we have entered our LCD screen section with a short introduction content. So now let's move on to our other lessons and check our LCD screen with Arduino well. Yes, my dear friend, in this lesson we will learn about I2C. It's especially important that we know the structure of the I2C protocol, because there is an I2C module on the LCD screen we will use. I2C is serial communication protocol. Communication takes place over 2 lines. These are SDA and SCL. Both buses are bidirectional. That is, data can be sent and received. Communication with I2C is also based on the master and the slave relationship. For example, while our Arduino board is a master, our LCD screen is a slave, and we control the slave throughout the master. In addition, each device used in the I2C protocol has its own address. For example, like 0x27. We will use an address like this when using our LCD screen. In this way, we will prevent data from being lost while transferring our data. Finally, the communication between master of slave is of bit type. Since the microprocessor on our Arduino board is 8 bits, the data is transferred 8 by 1. Yes, my dear friend, in this lesson I wanted to inform you about I2C. So now let's continue with our next lesson. Yes, my dear friends, in this lesson we will add our LCD display library to Arduino IDE, which is necessary for us to use our LCD display. So let's get started. First of all, we need to download our necessary files as .zip files on GitHub. Now let's come and download it as a .zip file from here. So let's select this code section and let's select the download zip. And as you can see here, we have successfully downloaded this zip file. And as you can see here is our zip file. By the way, I will add this website to this video source section. So let's continue. Now we have to open the Arduino IDE. So let's open the Arduino. And here is the Arduino IDE. So if you want to add any zip file to the Arduino IDE, we have to move to the sketch section. And as you can see here is the same as include library. So let's move to this, and as you can see here it says add.zip library. So now let's select this, and also we have to add our Arduino Liquid Crystal I2C library master. And also let's move to the desktop section and let's select this zip file. And also I click the open button. And as you can see here, we have successfully added to our library. So let's check it out now. Open the sketch section and move to the include library. And as you can see here is the our library. So now let's select this. And as you can see here, we have successfully included our library. So now let's verify our code. And let's write here, for example, as LCD. So now let's save this file. And as you can see here, compiling is done. So we have successfully added it. Alright my friend, in this lesson we learned how to add our library to the Arduino IDE. So let's move on to our next lesson. Yes, my dear friend, in this lesson we will learn our connection diagram so that we can control our LCD screen. As you know, in our previous lessons, I told you the GND line of the GND line. I said that the VCC line should be connected to the 5V line. For this reason, let's connect our GND, that is our ground line, to the GND line on our Arduino board. Let's connect the VCC, that is the power line, to the 5V line on our Arduino board. Our other lines are SDA and SCL. Since we will use our Arduino Uno board, we need to use I2C lines especially set for our board. SDA pin is set as analog 4 pin on Arduino Uno board. For this reason, we will connect the SDA pin on our LCD screen to the A4 line. Finally, there is the connection of our SCL pin. SCL pin is set as analog 5 pin on our Arduino Uno board. For this reason, we will connect the SCL pin on our LCD screen to the A5 line. Yes, our connection diagram is up to here. Let's move on to our next lesson and print text on our LCD screen. Yes, my dear friends, in this lesson we will write the necessary code so that we can print text on our LCD screen. As you know, we made our connection in our previous lesson. Now let's open the Arduino IDE. So let's click the Arduino app. And as you can see, here is our source code section. And also, as you know, we added our library. So our library is liquid crystal _ I2C. Let's come and include our library. So let's write here include liquid crystal _ I2C dot H. And as you remember, here is our I2C LCD screen library. So let's continue. If you want to use our LCD screen, the action we need to do is to call a class in our library. Our class name and library name are the same, so let's come here and write liquid crystal _ I2C. And of course we need to give our class a name, so let's put a space, and for example let's write my _ LCD. Here is our LCD screen name, and also we need to open parentheses, and let's close the parentheses, and also do not forget to use semicolon. And then let's move inside of our parentheses. We will enter 3 different parameters inside of our parentheses, our my LCD parentheses. Our first parameter will be the address of our LCD screen. In general, the address of I2C supported LCD screen is 0x27. So that is our LCD screen address. And then let's put a comma, and also we will enter the second parameter. Our second parameter is the number of columns. As you know, my LCD screen columns is 16. So I will write here 16, and of course our last parameter is our row count. As you know, our row number is 2. Therefore, let's define the value 2. After introducing our LCD screen, we need to start our screen in the setup function. Our required method to start our LCD screen is the begin method. Before we write our code inside of our setup function, let's delete our comment. And also let's call our LCD screen variable. So our variable name is my _ LCD, and also put a dot, and let's write here begin, and also open and close parentheses, and let's put a semicolon. If you do something like this, we will have started our LCD screen. So now let's continue. What we need to do now is to specify the position of the text. We will print before printing the text on our LCD screen, and also this is done with the set cursor command. So now let's move inside of our loop function, and let's write here my _ LCD dot set cursor, and also open and close parentheses, and let's put a semicolon, and let's move inside of our parentheses. We will enter the 2 different parameters here. Our first parameter will be our number of columns, and also our second parameters will be number of rows. So if I write here 0, 0, this is our beginning point of our LCD screen. And also let's move to a new line, and now let's write the text. If you want to write any text on our LCD screen, we have to use print function. So let's write here Firstly, let's call our LCD screen variable. So our LCD screen variable name is my underscores LCD, and also put a dot, and let's call our print function. And also open and close parentheses, and let's put a semicolon. And let's move inside of our parentheses. Let's create double quotes here. And let's move inside of our double quotes. For example, let's write hello world. Alright, we are done. So now let's verify our code, and also let's save our file. For example, let's write here my underscores LCD, and also let's click the save button. And as you can see here, the compiling is done. So now let's upload our code to the Arduino. And as you can see here, the uploading is done. So now I will share my camera with you. And as you can see here, we have successfully printed text on the LCD screen. So now let's continue with our next lesson. Yes, my dear friend, in this lesson we will learn how to clean our LCD screen. In order to perform this operation, we need to learn a new method. The name of this method is clear. We can clear our LCD screen with the clear method. So let's get started. First of all, let's include our LCD screen library. So let's move to the top, and let's include our liquid crystal underscores I2C .h library. And then let's move to a new line, call our liquid crystal I2C class. So I will write here liquid crystal underscores I2C, and also we have to set a name here, so put a space and let the class name be, for example, LCD, and also open and close parentheses and put a semicolon. And let's move inside of our parentheses. First of all, we have to define our LCD screen address as 0x27, and also put a comma, and the second parameter will be our column number. So our column number is 16, and also we have to define last parameter. Our last parameter will be our raw number. So our raw number is 2. If you do something like this, we have successfully introduced our LCD screen. And then let's move inside of our setup function, and let's start our LCD screen. So let's write here lcd.begin, and also open and close parentheses and put a semicolon. And then let's move to the loop function, and let's delete this comment. Alright, let's do an example here. For example, let's print hello for 1 second on our LCD screen, then let's delete it, then let's print see you for 1 second, and also delete it again. So now let's move to the loop function here, and also we have to call our setCursor functions. So let's write here lcd.setCursor, and also open and close parentheses and put a semicolon, and let's move inside of our parentheses. The first parameter will be our column number, so I will enter 0 because I will output at my starting position. So my starting position is 0, 0. That's why we define as 0, 0. And also let's move to a new line, and let's call our print function because we will print hello on our LCD screen. So let's write here lcd.print, and also open and close parentheses and put a semicolon, and move inside of our parentheses. Let's create double quotes, and let's write here hello. And then let's move to a new line, and let's call our delay function because we will keep it on the screen for 1 second. So that's why we call our delay function. So let's write here delay, and open and close parentheses and put a semicolon and move inside of our parentheses. Let's define 1000 to inside of our parentheses, and also we will learn a new function here, and also we can say method too. So our new function is clear. So if you want to use clear function, firstly we will call our LCD variable name. So my LCD variable name is LCD, and then put a dot, and let's write here clear and open and close parentheses and put a semicolon. If you do something like this, we will clean our LCD screen. So let's continue. So now let's move to a new line and call our print function again, because we will print CU. That's why we call again print function. So let's write here lcd.print open and close parentheses and put a semicolon and move inside of our parentheses. Let's create double quotes and let's write here CU. And then let's call our delay function again, because we will keep it on the screen for 1 second. So let's write here delay open and close parentheses and put a semicolon, and let's define value 1000. And then let's clear screen again. So let's write here lcd.clear open and close parentheses and put a semicolon. Alright my friend, we are done. So now let's verify our code. So let's write here clear and let's save this file. And as you can see here, the compiling is done. So now let's upload our code. Alright my friends, we are done. So now I will share my camera with you. As you can see, we were able to successfully clear our screen and print what we want to within 1 second. Alright my friend, in this lesson we learned how to clean our LCD screen. So now let's move on to our next lesson. Yes my dear friends, in this lesson we will learn how to create our own spacious characters. First of all, each text field on our LCD screen consists of 5 columns and 8 rows. We can manipulate these columns and rows and create special characters. Let's find out how we can do it now. So let's get started. Firstly, we will perform each operation over the byte data type. And as you can see, here is the byte array. And also there is a web page we can use here. I will add this web page to the resources section. If you want to create a special character, we have to choose our character from the green area you see here. So here is the green area. If I choose any squares, as you can see, our data type is changing. So let's make a smiley face now. So here is the clear button. Let's click this. And also let's choose 2 eyes. And also smiley face. And as you can see, here is our special characters. And as you can see, here is the byte type variable. So now let's copy this. And then let's open the Arduino IDE. And also let's move to the top and let's paste it here. So here is our special character. And also let's include our I2C LCD screen library. So let's write include liquid crystal underscores I2C.h. And also let's call our liquid crystal class. So I will copy this and let's paste it here. And also let's define a name to our class. For example, let's set it as LCD and also open and close parentheses, and let's put a semicolon and let's move inside of our parentheses. As you remember, our first parameter will be our LCD screen address. So my LCD screen address is 0x27 and put a comma, And our second parameter will be our number of columns, so I will define as 16. And also the third parameter will be the number of rows, so let's set it as value 2. And also let's move to the void setup function. Let's delete this comment. And also let's call our begin function. So I will write lcd.begin and also open and close parentheses and put a semicolon. And then we will learn a new function here, and also we can call it as method. So our new function name is createChar. Let's call our createChar method lcd.createChar and also open and close parentheses, and then let's put a semicolon. And let's move inside of our parentheses. We will enter two different parameters here. Our first parameter will be the ID number. So thanks to this ID number, we will able to print our special character. For example, let's define as value 0 and also put a comma, and our second parameter will be our byte variable name. So our byte variable name is custom char. So let's write here custom char. And also let's move to a new line and let's call our setCursor function. So let's write here lcd.setCursor and also open and close parentheses and put a semicolon, and let's move inside of parentheses. Let's define as beginning point, so 0, 0. And then let's move to a new line and we will learn a new function here too. Our function name is write function. With this function, we can show the data in our ID number on our LCD screen. So let's write here lcd.write open and close parentheses and also put a semicolon, and let's move inside of our parentheses. We will define a one parameter here. So the parameter will be the ID number. As you remember, our ID number is 0, so I will write here 0. If we do something like this, we get the result we want. So now let's verify our code. Let the name be, for example, char, and also let's save this file. And as you can see here, we didn't get any error, so now let's upload our code to the Arduino board. Alright, we are done. So now I will share my camera with you. And as you can see here, we have successfully created our custom character. Yes, my dear friend, we learned how to create our special character in this lesson. Let's continue with our next lesson. Yes, my dear friend, in this lesson we will learn about the module that necessary for us to perform our mimic movements. The module name we will use is MediaPipe. This module, together with deep learning, can detect the landmarks of our faces. We will also identify the landmarks in the lip area and learn our facial expressions when we smile or are sad. So let's get started with the introduction lesson. Look, so as you can see here, let's learn what is MediaPipe. MediaPipe, it's a deep learning module developed by Google. And also, along with the MediaPipe, facial landmarks may be found. As you can see here, we have two different images. Here and here. The landmarks on the faces are here. Of course, after finding the landmarks here, we need to find the lip areas with the indexing method. So, what do I mean? We have a representative image, as you can see here, also available in various numbers. For example, as you can see here, 103, 54, for example 333, and also for example 424. In fact, each of these numbers represents a landmark, We will learn our facial expressions through two indexes in the lib area, so here and also here. And in this way we will able to learn our facial expressions and print our facial expressions on our LCD screen. Yes, my dear friends, in this lesson we learned about the MediaPipe module and about face landmarks. Let's move on to our next lesson and draw a face landmarks. In this lesson, we will learn how to obtain images using the webcam on the computer. First of all, if we are going to use a webcam, we should know about the following. When we want to show the webcam or video, we observe the images flowing in sequence. And when we want to open webcam with OpenCV, we have to do it in a while loop, because the webcam will read the sequenced images and output to us. So let's learn to use the webcam with the OpenCV module. Firstly, let's move to the project folder and let's create a new Python file. And let the Python file name be, for example, webcam, and also press enter. And now let's import our OpenCV module. Let's write here import cv2. And now let's move to a new line. If we are going to use a webcam, we have to learn a new class. The name of this class is video capture. So let's create a new variable here. Let the variable name be, for example, webcam, and also put a equal sign. And then let's call our new class cv2.video capture, and also open parentheses. We need to enter the values 0 or 1 in the parentheses because this values is default. Since my webcam value is 1, and I will enter 1 value. And also, however, your webcam value may be 0. Don't forget to try both. And now we have to create a while loop. So let's write here while, and also open parentheses, and let's write in the parentheses true, and also put a colon, and move inside of the while loop. What we need to do now is to create two different variables, because the first variable we will create will be the control variable. The other variable we will create will be the matrix that allows us to output image. So right here, let the first variable name be control, and put a comma, and let the second variable name be, for example, frame, and also put a equal sign. And we have to read our webcam object. So let's write here webcam.read. If we do like this, we have successfully read our frames. So let's move to the new line. What we need to do now is to output our frame variable with the IamShow function. So let's write here cv2.IamShow, and also open parentheses, and let the window name be, for example, result, and put a comma, and let's write here frame. And finally, what we have to do is create a condition. So let's write here if, and also open parentheses. This condition will allow us to finalize our code. Here we will set the waitkey function as the response time. So let's write here cv2.waitkey, and also open parentheses, and let's give the 10 value. And also we will use the ampersand sign. So put a space and write ampersand sign. And also we have to put a space. And we will define a letter on the keyboard with the ORD function. So let's write 0xff is equal to ORD function, open parentheses, and let's create quotes, and let's write here, for example, Q, and now put a colon, and let's write break. Why did we do like this? Because if we do not do this, the system will give an error. The operation we have done in the condition if we press Q key for 10 milliseconds, our code will over. So now let's run our code. As you can see here, we have successfully get an output using our webcam. Now I will show you my hand, and here this is my hand. Alright, it looks perfect. Alright my friend, in this lesson we learned how to obtain images using the webcam on the computer. So let's continue with our next lesson. Yes my dear friend, in this lesson we will learn how to draw our facial landmarks using MediaPipe module. So let's get started. First of all, let's move to our project folder and let's right click and move to new, and let's create a new Python file here. For example, let the Python file name be media_test, and also let's press enter. And then let's import our MediaPipe module and also OpenCV module. So I will write here import CV2, and also let's move to a new line and let's import our MediaPipe module. Import MediaPipe. And also, by the way, I will use MediaPipe module as MP. And if we do something like this, we have successfully imported our modules. So now let's move to a new line and let's create a new variable here. So our variable will be webcam. So let's create webcam variable and put an equal sign. And then let's call our video capture class cv2.video capture, and also open and close parentheses, and let's assign it to value 1. If your webcam value is 0, you should assign 0. And then let's continue. So now let's move to a new line. Now we will learn to use the structures inside our MediaPipe module. The first of these will be the face mesh command. We will use our face mesh function with this command. In this way, we will be able to detect our facial landmarks. For this reason, let's create a new variable here. Let the variable name be, for example, mp_face, and also put an equal sign, and let's write here mp.solutions.face_mesh. If you do something like this, we have successfully completed our first detection landmarks. So now let's continue and let's move to a new line. In this new line, we will create a new different variable here. With this variable, we will draw our facial landmarks. So let's write here mp_drawing, and also put an equal sign, and let's write here mp.solutions.drawing_utils. Alright, we are done. What we need to do now is to use the face mesh function. First, let's call the with command. So let's write here with, and then let's call our face mesh function. This is a new function which we learn. So let's write here mp_face.faceMesh. And also open and close parentheses, and also all of these structures we will use as, for example, face_mesh, and also put a colon. And then let's move inside of our parentheses. We will enter two different parameters here. The first parameter will be our detection confidence, and also the second parameter will be tracking confidence. So let's write here min _detection _confidence, and put an equal sign, and let's assign it to, for example, 0.5. If you do something like this, it will detect with 50% or more accuracy. And also let's put a comma, and let's write here min _tracking _confidence, So I will assign it to 0.52. And also let's move inside of our width indentation. And then let's call our while true loop because we will get the frames from the webcam. So I will write here while true and also put a colon, and let's move inside of our while true indentation. So now we will create two different variables here. Our first parameter will be the control, and also our second parameter will be our frame. So let's write here frame and put an equal sign, and let's read our webcam. So let's write webcam dot read and also open and close parentheses, and let's move to a new line. So we will check our control variable. If the control variable is equal to false, so we will terminate our code. So let's write here if our control variable is equal to false, let's break our code. And also let's move to the while loop. Alright my friend, now we will convert our frame to RGB color format, because in this way we can perform a more precise detection process. So now let's create a new variable here. For example, let the variable name be RGB and put an equal sign, and also let's call our CVT color function. And as you know, our first parameter will be our frame matrix. So let's write here frame, and also our second parameter will be the cv2.color underscores bgr to RGB. Alright, we are done. So now let's move to a new line. What we need to do now is to process our face mesh variable and assign our RGB frames with the process function. So let's create a new variable here. For example, let's write result and put an equal sign, and let's call our face mesh and put a dot, and let's call our process function. And also we will enter one parameter here. Our one parameter will be our RGB frame, and as you remember, our RGB matrix name is RGB, so I will define RGB here. And also let's move to a new line. So now let's create condition here, and let's write here result dot multi underscores face underscores landmarks, and also put a colon and move inside of our if condition. If we do something like this, it means that the detection process is being performed. So now let's draw our facial landmarks. As you remember, our landmarks is like index, so we should create for loop here. For example, let the element name be face underscore landmarks in result dot multi underscores face landmarks, and also put a colon, and let's move inside of our for loop. Alright, so now we will draw landmarks of our facial landmarks. If you want to do this, we have to use np drawing variable. So let's write here np underscores drawing, and also we will learn a new function here. So put a dot, and let's call our new function. Our new function name is draw underscores landmarks, and also open and close parentheses. Inside of parentheses we will enter three different parameters here. So our first parameter will be the frame matrix. I will write here frame. Our second parameter will be element name. So as you know, our element name is face landmarks. So let's write here face underscores landmarks and put a comma. And also as the last parameter, we will enter the ready parameter to draw our facial landmarks. So our ready parameter is face mesh tessellation. If you want to use face mesh tessellation, we will write here np underscores face dot face mesh underscores tessellation. Alright, we are done. So now let's move inside of our while loop indentation and let's call our IAMShow function. So let's write here cv2.IAMShow and also open and close parentheses. Let the window name be, for example, test, and also our matrix variable name be our frame matrix. So let's write here frame, and then do not forget to use our waitK function. So let's write here if cv2.waitK open and close parentheses, and let's assign it the value 10 is equal to ESG button. Let's break our code. Alright my friend, we are done. So now let's run our code. And as you can see here, we have successfully reached our facial landmarks. Yes, my dear friends, in this lesson we learned how to draw landmarks of our face. So now let's move on to our next lesson. As you know, when we run our code, as you can see, there are lines and circles covering my face. These lines and circles are very huge. Let's come now and change the properties of these lines and also circles. So let's get started. First of all, we need to change two parameters in the draw landmarks function so that we can change our physical properties. Our first parameter is landmark drawing spec. So let's write here, put a comma, and let's write landmark underscores drawing underscore spec, and also put an equal sign. And then we will use a new function here. With this function, we can change physical properties of the landmark points. Our new function is drawing spec. If we want to use this function, we have to use our mp drawing variable. Firstly, let's write here mp underscores drawing, and let's call our new function. Our new function name is drawing spec, and also open and close parentheses. And then we can enter three different parameters here. Our first parameter, for example, let's change the thickness value. So let's write here thickness, put an equal sign, and for example let the thickness value be value 4, and also put a comma. And our second parameter will be our circle radius parameter. So let's write here circle underscores radius, and also put an equal sign. Let the circle radius variable be value 3, and also our last parameter will be our color. For example, let the circle color be blue color. Let's create a tuple here. If you want to change circle color as blue, we should write here 255,0,0. If we do something like this, we have successfully changed our circle color. So now let's check our code. Let's run our code. Alright, we have an error. Oh yes, we didn't define our color parameter. So let's write here color and put an equal sign. Alright my friend, we are done. So now let's run our code. Yes, we get an error. Yes, I found this. We wrote here the letter B, so we should write here landmarks, not landmarks. So let's run our code now. And as you can see here, we have successfully changed our color of the landmarks points. So let's continue. For example, let's decrease our thickness value. For example, let's write here value 2. And let's change our circle radius. For example, let's write value 2, and let the change color as red. So let's write here 255. So now let's run our code. And as you can see here, it looks perfect. Now let's continue. If you want to change our lines, we will define a new parameter here. So our new parameter name is connection underscore drawing underscore sketch, and also do not forget to use equal sign. And then let's call our drawing sketch function. So let's write here mp underscore drawing dot drawing sketch, and also open and close parentheses. For example, let's change the thickness value. So let's write here thickness and put an equal sign, and for example let the thickness value be value 1 and put a comma, and let's change our color. So let's write here color and put an equal sign, and let's create a new tuple here and move inside of our tuple. For example, let the line's color be green. So let's write here 0, 255, 0. And now let's run our code. And as you can see here, we have successfully changed physical properties of our lines. So for example, let's continue. Move to the landmark drawings page, and let's change our thickness value as value 1, and let's change our circle radius value as value 1. And now let's run our code again. So here it looks perfect. Alright my friend, in this lesson we learned how to change physical properties of our lines and also our landmark points. So let's continue with our next lesson. Yes my dear friends, in this lesson we will install the necessary module for communication between Arduino and Python. So why are we going to use this module? Because with deep learning we need to transmit a data that we are smiling or sad to the Arduino board. For this reason we need to take advantage of the serial module. Let's move on to the installation now. So let's get started. First of all, let's open the PyCharm IDE, and then let's move to the terminal section, and let's write here pip install PySerial, and also let's press enter. And as you can see here, we have successfully installed PySerial 3.5 version. So let's check our serial module. Let's move to the project folder and let's right click and let's create a new Python file here. For example, let's say test underscore serial, and let's press enter. And then let's import our serial module. So let's write here import serial. And let's move to a new line and let's call our print function, and let's write here serial dot underscores version underscores. So now let's run our code, and as you can see here we have successfully installed our serial module, and our serial module version is 3.5. Yes my dear friends, in this lesson we learned how to install PySerial module. So let's move on to our next lesson. Yes my dear friends, in this lesson we will write our Python codes for our project. So let's get started without wasting any time. Before we started, let's move to the project folder and let's create a new Python file here. Let the Python file name be, for example, final underscores project, and also let's press enter. And as you remember, we will import our modules. First, let's come and include our OpenCV module. So I will write here import CV2, and also let's move to a new line and let's come and import our MediaPipe module. So let's write here import MediaPipe. Let's use this module as MP, and then let's move to a new line, and of course let's not forget to import our serial module, which is necessary for us to send a signal to our Arduino board. So let's write here import serial, and also let's move to a new line. So now let's call video capture class for getting frames from our webcam. So let's create a new variable here. Let the variable name be, for example, webcam, and put an equal sign, and let's call our cv2.videoCapture class. And also open and close parentheses, and I will define the first parameter as value 1. And now let's write our face mesh codes, which are necessary for us to detect our facial landmarks. So let's create a new variable here. Let the variable name be, for example, mp underscores face, and also put an equal sign, and let's call our face mesh. So I will write here mp dot solutions dot face underscores mesh, and let's call the command for drawing. So let's write here mp underscores drawing and put an equal sign, and let's call drawing utils. So I will write here mp dot solutions dot drawing underscores utils, and also let's move to a new line. In this new line, we will learn a new command. This new command is inside of our serial module. With this command, we will be able to enter our port information, and we will adjust our serial communication speed, and the other name is baud rate speed. Our new command and also our new class name is serial. So let's create a new variable here. For example, let the variable name be Arduino, and also put an equal sign, and let's call our serial, and also open and close parentheses. We will define two different parameters here. Our first parameter will be our port number, and also our second parameter will be our serial communication speed. The port information is the USB line to which the Arduino board is connected. If you want to define port information, we should create single quotes, and also we will write here com, and then we will define our port number. So my port number is 5, so I will define as com5, and also let's enter the second parameter. Our second parameter is baud rate speed. In general, the baud rate speed is set to 9600. For this reason, let's enter the value 9600. Yes, my dear friend, we have created our necessary modules and variables in this lesson. So now let's continue with our other lessons and realize our project step by step. Yes, my dear friend, in this lesson let's continue from where we left off. As you know, we made the necessary definitions in our previous lesson. Now let's call our face mesh function. So let's get started. As you know, if you want to use face mesh function, we needed to call it using the with structure. So let's write here with, and also let's call our mp face variable, and also put a dot, and let's call our face mesh. And then, as you remember, we will define two different parameters here. Our first parameter will be the detection confidence. So let's write here min underscores detection underscores confidence, and also put an equal sign, and let's define this parameter as 0.5, and also put a comma. Our second parameter will be the tracking confidence. So let's write here min underscores tracking underscores confidence, And also let's define this parameter as 0.52, and also let's use this structure as face mesh underscores mesh. And also do not forget to use colon, and let's move inside of our width structure. In this new line we will call our while true loop, because as you know we will get frames from the webcam. So let's write here while true and put a colon, and let's move inside of our while loop, and then we will create two different parameters here for reading webcam. So let's write here control, and also our second variable will be frame, and then put an equal sign and let's read our webcam. And then let's move to a new line and let's call our if condition. If control variable is equal to false, let's break our code. And also let's move to the inside of our while loop. If we wanted to better display the landmarks on our face, which you know we had to change our color format. For this reason, let's come and convert our image to RGB color format. So let's create a new matrix here. For example, let the matrix name be RGB and put an equal sign. And if we want to convert our image, we should use CVT color function. So let's write here cv2.cvt color and open and close parentheses. Our first parameter will be the source matrix. So our source matrix name is frame. So I will write here frame. And our second parameter will be the cv2.color underscores bgr to RGB. And then let's move to a new line. In this new line we will process our face mesh variable. So let's create a new variable here. For example, let's say result and put an equal sign, and let's write here face underscores mesh dot process. And as you remember, we have to define one parameter here. Our parameter will be our RGB color format matrix. So let's write here RGB, and also let's move to a new line. In this new line, we will come and reach the height, width and number of channels of our frame matrix, because we need to think holistically while performing the detection process. So now we will create three different variables here. Our first parameter will be the height and put a comma. Our second parameter will be the width, and also our third parameter will be the channels. And then put an equal sign, and let's reach our height, width and channels. If you want to reach these values, we need to use a new method here. Our new method is shape method. If you want to use shape method, firstly we should write matrix name here. Our matrix name is frame, and put a dot, and let's write here shape. If we do something like this, we have successfully reached our height, width and channels values. Alright my friend, so now let's move to a new line. So now let's create a new if condition here. I will write if, and let's check our result multi-phase landmarks. So let's write here result dot multi underscores phase landmarks. And also put a colon, and let's move inside of our if condition. In this condition we will create for loop here, because we will find our facial landmarks. So let's write here for. So let's create a new value here. Our value name be, for example, face underscores landmarks, and put a space, and let's write here in result dot multi underscores face landmarks, and also put a colon, and let's move inside of our for loop. Alright my dear friend, what we need to do now is to reach the special facial landmarks on our face. This lesson is up to here, because in the next lesson I want to talk to you about the theory of this. In this way, when we learn the theory and continue, our project will be more understandable. So let's move on to our next lesson. Yes, my dear friend, in this lesson we will learn how to reach the landmarks on our face. In fact, the points on our facial landmarks are kept in certain indexes. Since we will do operation based on facial expressions in our project, let's take our lips as a base. Each of our points in the lip area is specific. And the designated indexes hold the coordinates of the points in the face region. We will be able to benefit from the indices located in the corners of the lip area. In this way, we will be able to reach our coordinates and learn our facial expressions. Look, as you can see here, I have shown two different areas with the arrows. The indices of these 2 points are 306 and 61. Respectively, we will reach the x and y information of these indexes. Yes, my dear friend, in this lesson we learned our indexes in the corners of the lips. Let's move on to our next lesson and let's draw our points. Yes, my dear friend, in this lesson we will learn to reach our list defined in face landmarks. As you know, coordinate information is kept in the list we will reach. So let's start now and draw the landmarks on the lip corners. As you remember, our indexes of lip corners are 306 and also 61. So let's reach these points now. For example, let's create a new variable here. Let the variable name be, for example, point1, and let's put an equal sign and let's reach our landmark index. If you want to reach our landmark index, we have to write here firstly face underscores landmarks dot, let's write here landmark, and also let's create square brackets and let's write index number. So as you know, our index number is 306. If you do something like this, we can get the x and y coordinates. So now let's reach x and y coordinates. If you want to reach x and y coordinates, we should create x and y points. So let's write here basically x1 variable and put an equal sign, and let's write here point1 dot x. And of course, when we need to think holistically, we should multiply this value by width. So let's multiply by width. If you do something like this, we can successfully reach the x coordinate of the index number 306 in our lip corner. However, when we want to draw our point, we may encounter an error, because the value x1 here can be decimal. Pixels are rendered as integer. For this reason, let's come the multiplication here and do the int conversions. So let's move to the beginning point of letter P and let's write here int and open parentheses, and let's move to the end and close the parentheses. If you do something like this, we have successfully get the x1 value as integer. So now let's move to a new line and let's create a new variable here. Our variable name be y1, and let's get the value of y coordinate. So let's put an equal sign and let's call our int function, and let's write here point1 dot y multiply by height. Alright my friend, we are done. So now let's move to a new line and let's draw our point. If we want to draw our point, we should use circle function. So let's write here cv2.circle and also open and close parentheses. Our first parameter will be our output matrix. As you remember, we will show our frame matrix. So let's write here frame and put a comma. Our second parameter will be our center. If you want to define center point, we should create a tuple here, and then we will write here x1, y1. And also let's continue. So now let's put a comma, and our third parameter will be the radius. For example, let the radius value be value 2, and let's put a comma, and then we will define our color. For example, let the circle color be red, so let's create a new tuple here and let's write here 0,0,255, and then let's define the last parameter. Our last parameter will be the thickness, so let's define as 3, for example. Alright my dear friend, we are done. So now let's come and check it. Let's move to the while true indentation and let's call our IAMShow function. So let's write here cv2.IAMShow, open and close parentheses, and let the window name be, for example, final, and our second parameter will be the frame. So let's write here frame, and also let's move to a new line, and do not forget to create if condition, and also let's write here cv2.waitKey, and let's define as value 10 is equal to ESC key. So if I press the ESC key, our code will terminate. So let's write here break. Alright, so now let's run our code. And as you can see here, we have successfully drove the point, our lip corners. So here. Alright my friend, let's continue. Now let's create our other point now. Let's move to the inside of our for loop and let's create a new variable here. For example, let's write point 2 and also put an equal sign, and let's get the 61 index. So let's write here face underscores landmarks dot landmark, create square brackets, and let's write here 61. And now let's move to a new line and let's create a new x2 variable and also put an equal sign, and let's call our int function, and also let's write here point 2.x multiplied by width. And then let's move to a new line and let's create a new variable here. Our new variable name is, for example, y2, and put an equal sign, and let's call our int function and point 2.y multiplied by height. Alright, we are done. So now let's call our circle function. Let's copy this and let's paste it here, and also let's change the points x2 and also y2, and if you do something like this, we have successfully created our other point. So now let's run our code, and as you can see here, we are done. Yes my dear friends, in this lesson we learned how to reach our list defined in face landmarks, and also we learned to draw our points in the corners of the lips. So now let's move on to our next lesson and determine our facial expressions with mathematical calculates. Yes my dear friend, in this lesson we will learn about the distance formula between 2 points. It's important that we learn this calculation well, because we will learn our facial expressions with the distance between the 2 points we draw at the corners of the lips. So now let's get acquainted with our formula now. As you can see, we have a square root operation. So here is our operation. And our horizontal axis is defined by x points. So as you can see, here is the x2 and also x1 point. And also while our vertical axis is defined by y points. So here y2 and also y1. If we subtract our x1 value from our x2 and subtract our y1 value from y2 value, and if we take the second power of these values we subtracted, so here and here, and add them together, we can reach the result we want. Yes, my dear friend, in this lesson we learned about the formula that is necessary for us to realize our facial expressions. Let's continue with our next lesson and learn the distance between our lip corners. Yes, my dear friend, now let's come and use our formula with software. First of all, we need to use the math module to use our formula. So let's move to the top and let's import our math module. So I will write here import math. And then let's move inside of our for loop and let's move to a new line and let's create a new variable here. For example, let the variable name be distance. And also let's put an equal sign. And now we will learn a new function here. This function about the square root. If we are going to do the square root operation, we need to call the sqrt function in the math module. So let's write here math.sqrt. And then let's move inside of our parentheses, sqrt parentheses, and of course we need to do exponential operations. For this we need to use the pop function. Pop function is inside of our math module. So let's write here math.pop and also open and close parentheses, and we will define two different parameters here. Our first parameter will be the base, and as you remember our base number is x2 minus x1. So let's write here x2 minus x1 and put a comma, and our second parameter will be the power. We will take the second power, so let's write here 2, and also let's outside of our parentheses and then let's put a plus sign, and also call again pop function here math.pop and also open and close parentheses, and then let's write here y2 minus y1 and also put a colon, and let's take the second power. Alright my friend, if we do something like this, we can successfully calculate the distance between 2 points. Now let's move to a new line and let's call our print function and open parentheses and let's print out variable distance. So I will write here distance, and now let's run our code. As you can see, we have reached numerical values. When I smile, my numerical value increases. When I am sad, my numerical value decreases. Yes, my dear friend, in this lesson we have reached the numerical values necessary for us to learn our facial expressions. Let's continue with our next lesson and send a signal to our Arduino board. Yes, my dear friend, in this lesson we will send a signal to our Arduino board. As you know, we calculated the distance between the lip corners in our previous lesson. These calculated values give us different results when we smile and different results when we are sad. Let's come and now create our conditions according to these values. Before we started, let's run our code. As you can see, when I smile, the values generally show 48 and above. For this reason, let's create a condition, and if our distance, so let's move to the for loop indentation and let's write here if our distance variable is greater than 48, let's send a signal to our Arduino board. If you want to send a signal to our Arduino board, we will learn a new method. If you want to use this method, we have to use our Arduino variable. First of all, let's write here Arduino variable and put a dot, and our new method is write method. With this method, we will send a signal to our Arduino board and also open and close parentheses. And let's write here letter B. Why did we do something like this? Because we will send a data as byte. The letter B here represents the word byte. And also let's move to the end and let's create single quotes. And for example, let's send a signal like letter capital A to our Arduino board. If you do something like this, letter A signal will be sent to our Arduino board. Now let's continue. Let's come now and send a different signal, this time when we are set. So let's move to a new line and let's move inside of our for loop indentation and let's call our elif condition. And as you remember, when we were set, the distance value were, for example, 42, 43, and also 44. So let's write here our distance variable is less than, for example, 46. Let's send a different signal to our Arduino board. So let's write here Arduino dot write and also open and close parentheses, and let's write here letter B and let's create single quotes. For example, let's send a data as, for example, letter B. If we do something like this, when we smile, letter A signal will be sent to our Arduino board when we are set the letter B. Yes, my dear friend, this is how our Python codes are in general. Now let's write our Arduino codes and test our project. Yes, my dear friend, in this lesson we will write our Arduino codes. First, let's come and include our LCD Display Library. So let's move to the top and let's include our liquid, crystal, underscores I2C.h, and also let's move to a new line and let's define our LCD screen. First, let's create LCD screen variable. So I will write here liquid crystal underscores I2C, and also let's give a name to our I2C LCD screen class. For example, let's say LCD and also open and close parentheses, and let's put a semicolon and let's move inside of our parentheses. As you remember, our first parameter will be our LCD screen address. So my LCD screen address is 0x27, and let's define number of columns. So our number of columns is 16 and put a comma, and let's define number of rows. So as you remember, our number of rows is value 2. And then let's move to a new line and let's create a new variable here. We will create a variable of type char. With this variable, we will read the data that comes from Python. So let's write here char and put a space and let's give a name. For example, let's write here incoming data and also put a semicolon. And then let's move inside of our setup function and let's start the LCD. So let's write here lcd.begin and also open and close parentheses and put a semicolon, and let's move to a new line and also let's start the serial port. If you want to start serial port, we should write here serial. The letter S should be capital. So let's write here serial.begin and open and close parentheses and put a semicolon, and let's move inside of our parentheses. We will define the baud rate speed. As you remember, our baud rate speed is 9600. And also let's move to a new line and let's call the set cursor function. So I will write here lcd dot set cursor and open and close parentheses, and let's move inside of our parentheses. We will define the beginning point, so our beginning point is 0, 0. Alright my friend, we are done. So now let's move to the loop function. Now what we have to do is create a condition here. With this condition we will learn whether the signal is coming to our Arduino board. So let's write here if, and also open and close parentheses, and let's create curly brackets and let's close the curly brackets. And then let's move inside of our parentheses and let's write here serial dot available is greater than 0. Our logic here will be as follows. If data comes to our Arduino board, the condition here will be true. And also let's move inside of our curly brackets and let's read the data. We will assign the incoming data to the variable named incoming data. So let's write here incoming data and put an equal sign and let's read our data. If you want to read our data, we should learn a new function. Our new function name is serial.read. And also open and close parentheses and put a semicolon. When we do something like this, we can learn the data coming to our Arduino board. So now we will create a new condition here. With this condition, we will check the data. For example, if the letter A signal comes, we will print smiling with our LCD screen. If letter B signal comes, we will print sad. That's why we create a new condition here. So let's write here if, open and close parentheses, and let's create curly brackets here. And then let's move inside of our parentheses and let's write here incoming data is equal to letter A. Firstly, let's call the setCursor function. So I will write here lcd.setCursor, open and close parentheses and put a semicolon. Why did we do something like this? Because in this way we can continuously print text at the starting point. So let's move inside of our setCursor function and let's define the starting point 0, 0, and let's move to a new line and let's call our lcd.print function and open and close parentheses, put a semicolon, and let's move inside of our parentheses. Let's create double quotes and let's write here smiling. And then let's move outside of our if condition and let's call our else if condition. With this condition we will check the letter B. So let's create parentheses and let's write here incoming data is equal to letter B. Let's create curly brackets here and let's call lcd.setCursor function, open and close parentheses, put a semicolon, and let's move inside of our parentheses. We will enter the parameter as 0, 0. Here is the beginning point. And also let's move to a new line and let's call the print function lcd.print, open and close parentheses and put a semicolon, and let's move inside of our parentheses, create double quotes, and let's write here set. Alright my friend, we are done. So now let's verify our code. So let's write here final project and let's save this file. Yes, we have an error because we have forgotten available parentheses. So let's create open and close parentheses. If you do something like this, we can successfully verify our code. So now let's verify again. Alright my friend, as you can see here the compiling is done. So now let's upload our code. And as you can see here, we have successfully uploaded our code. Now let's move to our next video and check the project we made. Yes my dear friends, we will now test our project. Let's come and run our Python codes. Now I will share the LCD screen with you. As you can see, we were able to send a signal to our Arduino board successfully, and we can get outputs according to our facial expressions. However, the text you see here are written on our LCD screen. In particular, I wanted to show you the error that occurred here. So, how can we fix this error? Actually, fixing this error is very simple. For this, it will be enough to make a small addition to our Arduino code. What we need to do is to clean our LCD screen before the setCursor function in our conditions. In this way, we can achieve the desired result. So now, let's open the Arduino IDE and let's move to the if condition here. And let's write here lcd.clear and also open and close parentheses and put a semicolon. And then let's move to the else if condition and let's write here lcd.clear again and also open and close parentheses and put a semicolon. And now let's verify our code. And also let's upload our code to the Arduino Uno board. Alright my friend, we are done. So now let's open the Python codes. So now let's run our code again. As you can see, we have reached the desired result. Yes my dear friend, there is no limit to what we can do in the software world. If there is a question or problem that you do not understand in the videos up to this point, please do not hesitate to ask. This is a servo motor you see in my hand. Servo is defined as a drive system that performs angular linear position, speed, and acceleration control in mechanism without error. In other words, it's a motion control mechanism. Servo motor are the most used motor type in robot technologies. In our other project, we will use a servo motor because we will do joint movement with the servo motor. Alright, we generally have 3 different lines in our servo motor. You see, the brown line is the ground line. So here is our ground line. And also the red is the 5 voltage line. So here, this is the middle line. And also the orange is our signal line. Together with Arduino, we can control our servo motor angularly. So now let's make our connection first and get our codes ready for use with Arduino. So let's get started. Alright, so here is our Arduino, and also we need some cable for connections between Arduino and servo motor, and let's do this operation now. So first let's start with our brown cable, and as you remember, the brown line is representing our ground line. So let's wiring to the ground. So you see here, let's focus this now. Alright, so let's select the ground, and also the middle, which color is red, we should connect to the 5 voltage pin. So here is our 5 voltage. And also the last one is representing our signal, so we should use PWM port. So let's do this now. I will choose the 9 port. And by the way, you can also use different PWM ports in the Arduino. So let's select 9th port now. Alright my dear friend, we are done. So now let's connect our Arduino to our computer. Alright, we are done. Yes my dear friend, in this lesson we learned what is servo motor and also how to connect servo motor to the Arduino. So now let's move on to our next lesson and let's learn how to control servo motor using Arduino. Yes my dear friends, in this lesson we will provide servo motor control with you. In order to do this operation, first of all let's open the Arduino IDE. So I will open my Arduino IDE now. So let's click this and also it's opening. And you see here, and also let's create a new source code now, and here is our new source code. And also then we need to add a new library to our source code for servo motor control. The name of this library is servo.h, so let's include this now. As you know, if you want to add any library to our Arduino code, what we have to do now is to include our library. So for this operation, first let's use an hashtag here and let's write include, and also let's use less and larger sign, and let's move inside of our less and larger sign and let's include our servo.h library, and we are done. And also if we want to control our servo motor, what we have to do now is to create a new object, which is our servo object. So for this, we need to learn a new object here. The name of this object is servo, and put a space, and then we need to give a name to our object. For example, let the object name be servo, and also put a semicolon. Alright, we are done. So now let's define our pin number of our servo signal port. As you know, this is 9th port. And also for this operation, let's move inside of our setup function, and also let's delete this comment, and then we need to call our object variable name here. So this is servo, as you know, and also we need to learn a new function here. With this function we will define our pin number. So the name of this function is attach, and also open and close parentheses and put a semicolon. And now we need to define our pin number. As you remember, our pin number is 9, and that's why I entered the 9 value as a first parameter. Alright, we are done. So now let's verify our code, and also let the file name be, for example, servo control, and let's save this file. And you see here the compiling is done. So now let's control our servo motor. For this operation we need to learn a new function in our servo object. The name of this function is write function. So if you want to use write function, let's move inside of our loop function and let's call our servo object again and put a dot, and let's call our write function and open and close parentheses and put a semicolon. Now we need to determine the angle of our servo inside of our parentheses. If we enter the value 90 here, the angle of our servo will be 90 degrees. So now let's check our code. For this, first let's verify, and you see here the compiling is done. And also I will show you my servo motor right now. Alright, so now I will upload my code to the Arduino. And you see here is our 90 degree of our servo motor. And for example, let's change our degree of servo motor. For example, let's change as 45 here. And if we run our code again, and you see here this is our 45 angle of servo motor, and for example let's change is 180, and if we run our code again, and you see here is the result. and also this is our 180 degree of our servo motor. So here is the result. And by the way, I want to give you some information about our servo motor. Our servo motor can rotate between 0 degree and 180 degree. That's why we need to define between 0 degree and also 180 degree. Alright my dear friend, in this lesson we learned how to control servo motor using Arduino Uno board. So now let's move on to our next lesson and let's build our second project. Yes my dear friend, in this lesson we will start to create our mechanism so that we can realize our project. As you know, we will make a project that we can move our arms as a representative in our project. With this project we will perform our elbow movements according to the distance between the shoulder and the wrist. So what do I mean? Look, here we have a piece from shoulder to elbow. We also have a piece that goes from our elbow to our wrist. We use image processing and computer vision when the distance between our wrist and shoulder is close. Here we will use a servo motor also. We will come and accordingly bring our wrist closer to our shoulder. So just like that. Of course, not limited to this, if it moves away, we will control our servo motor in the opposite direction. Actually, that is basis of our project. As you can see here, we have two different papers here. Actually, we divide our arm into two different parts. The first paper is representing from shoulder to elbow, and also its distance is 25 cm, and also the second one is represent our from elbow to wrist, and by the way, second part is 27 cm. In other words, we can actually think of it as a normal person's arm. Yes, in this lesson we learned about our project together with you and learned the dimensions of our arm parts. Let's continue with our next lesson and create our arm. Look, we have arm pieces that we have drawn here. Let's come and cut these parts and make them suitable for sticking on our cardboard. I come and take my scissors and start cutting. Look, this part of our arm represents from elbow to wrist, so we are done. So now let's come and cut our second part of arm. And of course, you can find all of the papers on source section of this video. And you can free to download and print these project sources. Alright my dear friend, we have successfully handled cutting operation of arm. In this lesson we cut our arm parts. So now let's move on to our next lesson and stick the pieces we cut on the cardboard. Alright my dear friend, so now let's continue. I prepared my parts of arm and cardboard. Now what we need to do is to stick our paper on the cardboard. After gluing, we will cut and paint our piece of arm cardboard. So now let's do this operation. Alright my dear friends, as you can see we have done the pasting process. Now let's come and cut it. Yes, we made our first cut. Now let's go and do this for the other cardboard. Yes, I cut it quickly here for you because I wanted to show you quickly. Now that we have cut our cardboard, we can paint our paper. I will use the cream color for this. Of course, you can also choose your own color. So now let's do painting operation. So I will take my color, and by the way I will also use crayons. Yes my dear friend, we have successfully painted our first part of our arm. So now let's do this operation for the second one. Yes my dear friends, as you can see we have successfully handled our painting operation. And for example, look at our arm now. If the wrist moves closer to our shoulder, we will control like this. And otherwise, if it moves away, we will control like this. So this is the basis of our project. Yes my dear friend, in this lesson we created our arm. So now let's continue with our other lessons and create our other mechanisms. Yes my dear friends, we have a rectangular cardboard as you see, so that we can fix the arm we will make. With this cardboard we can easily fix our arm. Of course, another issue is that our cardboard looks beautiful. For this, we will use two pieces of blue colored paper. Look, here I will come and fix my arm, and also I will place the shoulder and elbow part of my arm here. And then my servo motor will be fixed in the position you see. As you already know, we will use the servo motor as an elbow. Then the other part will be fixed on our servo motor. In this way, we will be able to perform the opening and closing operations of our arm. So now let's come and set up our background. Let's apply glue to the back of the papers you see here, then we paste it on our cardboard. Alright, so now let's paste our blue paper to the cardboard. So now let's do the same operation for second paper. So now let's paste our blue paper to the cardboard again. Alright, we have done our pasting process. Now I will share the size of the cardboard with you. Our cardboard is 48 cm wide and also 32 cm height. Alright, now that we know the sizes of our cardboard, so now let's cut the excess parts. Alright my dear friends, we have completed the cutting process. Now all we have to do is stick our fixed piece to our cardboard. Let's do this operation now. Yes my dear friend, we came and glued our fixed piece to our cardboard. This lesson is up to here. With this lesson we have come to the end of our setup. Let's continue with our other lessons and let's do the other operation for our setup. Yes my dear friends, in this lesson we will continue from where we left off. In this lesson we will fix our servo motor to our elbow. Look, as you can see here we calculate the midpoint of our elbow. What we need to do is fix our servo with the help of hot silicone. So let's do this operation now. As you can see, the midpoint of our elbow is defined by the blue line. Also, I would like to inform you about this issue. It's important that we position our servo motor, because we will control our servo motor between 180 and 90 degrees. For this reason, we must position like this, as you can see here. So, let's continue. First of all, let's squeeze our hot silicone to the middle point. Then, let's keep our servo motor on it. Now what we have to do now is to keep our servo motor on the hot silicone. Let's hold on a little. When we control the servo motor, you see here, it looks perfect. So let's continue now. And you see here, we have successfully pasted our servo motor to the elbow of our arm. So now let's do glue operation between our servo motor and also our second part of arm. So let's do this operation now. You see here, this is the middle point of our second part of our arm, and also it must be on our servo motor parts, so that's why we should pay attention to. And also with this operation we can successfully do glue operation for our arm project. Finally, let's come and fix our other part to our servo motor, and by the way, we need to hold it longer while doing this process. Yes, my dear friend, as you can see, we have successfully completed our setup. So now let's continue with our other lessons and write the necessary Arduino and image processing codes. Yes, my dear friends, in this lesson we will write the Python codes of our project together with you. So let's get started. Let's move to our project folder and let's create a new Python file here. And let the Python file name be pose detection, and also let's press enter. Let's go ahead and import our required modules. Let's import our OpenCV module for our image processing codes. So I will import our OpenCV module, and of course let's import our MediaPipe module to detect the landmarks of our arm. For this, let's import our MediaPipe, and also let's use our MediaPipe as MP. And as you know, we need to import the serial module in order to send a signal to our Arduino board. So for this, let's import serial module. Finally, let's import our math module here. With this module, we will calculate distance between wrist and shoulder. So I will import my math module here. So we are done. So now let's open our webcam. For this operation, we need to call video capture class. So now let's create a new variable here. We can also say object. For example, let the object name be webcam and put an equal sign, and let's call our cv2.videoCapture class. And as you know, we can enter two different parameters here. These are 0 and 1. And also my webcam ID is 1, so that's why I entered value 1 here. If your camera ID is 0, you should enter the 0 in the parentheses. So let's continue. Now let's come and change the properties of our camera. In this way, we will be able to make a more accurate detection process. So for this, first we should call our webcam object, and also we should call a new method in webcam object. So which name is setMethod. With this method, we can successfully change width and height of our webcam. And also, if we want to use setMethod, we should enter two different parameters here. The first parameter will be our properties ID. For example, if I enter value 3 here, we can successfully change the width of our webcam. If we want to change width of webcam, let's put a comma and let's enter the width size here. For example, let the size be 1280.
And also let's move to a new line. So now let's change height of webcam. So let's call here webcam.set again. And now we should enter the value for here. With this value we can successfully change the height of webcam. So for example, let the height of webcam value be 720. And also if we run our code like this, and you see here we didn't get any error. So let's continue. Now let's come and define our variable required for arm detection. For this operation we should use our MediaPipe module. So let's move to a new line and let's create a new variable. Here we will assign a new Python file to our variable. For example, let the variable name be mp_pose. And also put an equal sign. And also if you want to detect arm detection, we should call here mp.solutions.pose. And we are done. And finally we need to define our ports in order to send a signal to our Arduino board. For this, let's create a new variable. Here let the variable name be, for example, my Arduino, and put an equal sign. And for this operation let's call our serial module, and also let's call our serial class. Open and close parentheses. In the parentheses we will enter two different parameters. Here the first parameter will be our port, and also the port value must be string variable type. So let's create double quotes here and let's define port number, which relationship with Arduino. So my port value is COM3, and also your port number can be different, and put a comma. And finally we should enter our baud rate speed. As a default the value is 9600. If we do something like this, we can successfully open our port, and also we can successfully send a signal to our Arduino board. Alright, yes my dear friend, this is how we define it in general. So now let's continue with our next lesson and write our other necessary codes. Yes my dear friends, in this lesson we will write the necessary codes to create our ARM model together with you. As you know, the variable we created here is actually the Python file. Now what we need to do is to open this Python file and define our required class. As you know, if you want to do this operation, first we should call here with structure, and also we will call here our Python file variable name. So as you know, this is mp_pose, and also put a dot. And if you want to detect any arm using MediaPipe module, we should call here pose class, and also open and close parentheses. In the parentheses we will enter three different parameters here. The first parameter will be our static image mode. So what is static image mode? Actually, if you want to assign value true, it allows us to detect with the webcam. So that's why we should assign as value true. So let's call here static underscore image underscore mode, and also let's define as value true, and also put a comma. So now the second parameter will be our detection confidence. As you know, we will define as 0.5 because 50% accuracy is enough. So that's why we will define as 0.5 here, and also it represents 50%. And finally the last parameter is our min tracking confidence. It will be the same as our min detection confidence. So let's call here min tracking confidence, and let's define as 0.5. And also not limited to this, we will use all of these class as, for example, pose, and also put a colon, and let's move inside of our with structure. Alright, we are done. So now we should create a loop here. because we will get the frames from webcam. So this is a real-time application, that's why we need to call here while true loop, and let's move inside of our while loop. Alright my dear friend, we are done. So now we need to read our webcam. For this operation, as you know, we should create two different variables here. The first variable will be our control variable and the second parameter will be our frame. And also with this variable, we will get the frames from webcam. So for this reason, let the variable name be frame and put an equal sign, and let's call here webcam dot read method. So we are done. So now let's move to a new line. Now we need to change our color format. As you know, the default color format is BGR in OpenCV module. Actually, MediaPipe module supports RGB color format. That's why we have to change that. So for this, let's create a new matrix variable here. Let the matrix variable name be, for example, RGB. And also, if you want to change any color format using OpenCV module, we should call here CVT color function. So let's call cv2.cvt color, and also open and close parentheses. In the parentheses, we will enter two different parameters here. The first parameter will be our input matrix that we want to change color format. So as you know, this is our frame matrix. The second parameter will be our color format values. If we want to reach all of these color formats, so let's call here cv2.color underscore, and as you know, our color format is BGR, and also we want to use as RGB, so that's why we should write here BGR to RGB. So we are done. So now let's continue. Alright my dear friends, since we have changed the color format of our image, let's come and reach our webcam sizes. For this, as you know, we use the shape method. The reason we do this is because we have to think holistically the coordinates we have obtained, because the model we will create returns values between 0 and 1. That's why we should reach our webcam sizes. So for this, we should create three different variables here. The first variable represents our height, and the second variable represents our width of webcam, and also the third one is representing our channel number. So we should use as underscore here. And also let's put an equal sign and let's call here. As you know, if you want to use shape method using OpenCV, first we should call here our matrix variable name. So as you know, this is frame, and also put a dot and let's call here shape. And we are done. Now what we need to do is to process our model. As you know, if we want to do this operation, we should use process model in our model. So for this, let's move to a new line and let's create a new variable here. Let the variable name be, for example, result, and put an equal sign. And also if we want to process our model, what we have to do now is to call here our pose variable. So let's write here pose and also put a dot, and let's call here our process method, and also open and close parentheses. In the parentheses we will enter one parameter here. The parameter represents RGB color matrix. So as you know, this is our RGB. And if we do something like this, we can successfully process our model. Alright my dear friends, we are done. In this lesson, we learned the necessary steps to detect our model. Now let's move on to our next lesson and detect our arm and its regions. Yes, my dear friends, we will continue from where we left off in this lesson. In this lesson, we will perform wrist, elbow, and shoulder detection with you. As you know, we need to know the index number required to perform this operation. Look, there are indexes that we can use here. The ones we will use are the 16th, so here, 16th, 14th, and also 12 indexes. In this way, we can detect our arm representatively. So let's do this operation now. For this, let's open our PyCharm IDE again. In this time, we will create an if condition here, because with this condition, we will check whether there is arm contact or not. So for this, let's create if condition here, and also if we want to detect arm, what we have to do now is to reach pose landmarks in results. For this operation, let's call our result variable here, and also put a dot, and let's check our pose landmarks, and also put a colon, and let's move inside of our if condition. So now we need to get the landmarks of our special points. As you know, these are wrist, elbow, and also shoulder. For this, let's create a new variable here. Let the variable name be, for example, wrist, and also this variable represents our wrist coordinate, and also put an equal sign. And by the way, if you want to reach the wrist coordinate of our arm, what we have to do now is to reach the landmark of our pose landmarks. For this, let's call here our result variable again, and let's reach our pose landmarks. And not limited to this, if you want to reach the landmark, we need to call here dot landmark. And also this list represents coordinate of our wrist. And also let's create square brackets. And by the way, if we want to reach the wrist coordinate, as you know, we need to reach our index number of our wrist. So this is 16. And we are done. And also let's move to a new line, and let's get the coordinate of our wrist. For this, let's create x and y variable, because these are representing our wrist coordinate. For example, let the x variable name be x1, and put an equal sign. And of course, we have to convert to integer conversion function, because as you know, pixels are made up of integers. So that's why we need to call here integer type conversion function, and also open and close parentheses, and let's reach our x coordinate of wrist. For this, let's call here our wrist variable, and if you want to reach the x coordinate, so let's write here dot x. And also not limited to this, we need to multiply this value with our width of our webcam, because we need to think holistically. So let's multiply by our width, and we are done. So now let's move to a new line, and let's do this operation for our y coordinate. So let's create a new variable here. Let the variable name be y1, and put an equal sign, and let's do integer type conversion again. And let's reach this time wrist.y, and multiply by this time. As you know, this will be our height value of our webcam. So we are done. So now let's draw a circle using these coordinates. For this, as you know, we should call here our circle function, and also open and close parentheses, and in the parentheses we will enter 5 different parameters here. The first parameter will be our output matrix that we want to show our circle. As you know, this is frame. And also the second parameter will be our center point. We have already calculated our center point of wrist. These are x1 and y1. And also the third parameter will be our radius. So let the radius value be, for example, 20. The fourth parameter will be our color. For example, let the color be red. So for this, let's define a 0, 0 and comma 255, and we are done. So now let's enter our last parameter, and the last parameter will be our thickness. If I set as -1 here, we will get the field circle. So this is great. That's why I entered -1 here. So let's continue. So now let's do this operation for our elbow of our arm. So let's create here a new variable. Let the variable name be elbow, and put an equal sign, and let's call this time result dot pose landmarks, and also put a dot again, and let's reach our landmark list, and open and close square brackets, and let's enter the index number of elbow. So as you know, this is 14. So let's enter here 14. Alright, we are done. So now let's get the x and y coordinate of elbow. So for this, let's create a new variable. Let the variable name be this time x2, and let's call our integer type conversion function, and let's reach elbow.x, and let's multiply this time our width. Alright, so let's do this operation for our y2 variable. So let's create y2, and let's call here integer type conversion function, and let's reach this time elbow.y, and let's multiply this time with our height. And also let's draw a circle for our elbow. For this, let's copy our circle function here, and let's paste it here, and just let's change the coordinates as x2 and y2. Alright, we are done. Finally, let's do this operation for our shoulder. Let's move to a new line again, and let's create shoulder variable, and let's reach this time our shoulder variable x and y coordinate. So for this, let's call result.pose landmarks.landmark, and also open and close square bracket, and as you know, the index number of our shoulder is 12th. So let's define as 12th. Alright, we are done. So now let's reach the x and y coordinate of shoulder. So let's create x3 variable, and let's call here integer type conversion function, and let's call our shoulder.x coordinate, and let's multiply with our width variable. And finally, let's create our y3 variable, and let's call integer type conversion function again, and let's reach our y coordinate of shoulder, and let's multiply this time with our height variable. Alright, and also let's copy our circle function again, and let's paste it here, and let's change just coordinates of circle as x3 and y3. Alright, my dear friend, we are done. In this lesson, we detected and drew the necessary arm regions together with you. So now let's continue with our next lesson and examine the output of the model we created. Yes, my dear friend, in this lesson we will test the code we wrote. First of all, let's come and view our frame matrix so that we can do this. For this operation, let's move outside of our if condition. And as you know, if you want to show any matrix using OpenCV module, what we have to do now is to use IAmShow function. So let's use IAmShow function now. For this, let's call here cv2.IAmShow, and also open and close parentheses. In the parentheses, we will enter two different parameters. The first parameter will be our window name, and let the window name be, for example, arm detection. And also the second parameter will be our matrix variable name that we want to show on the screen. As you know, this is our frame matrix. So let's display now our frame matrix, and also not limited to this, we should create a new condition here because we will get frames from webcam. So as you know, this is the default settings that we want to display our webcam on the screen. So for this, let's create an if condition here, and if I press 10 milliseconds for ESC key, let's break our code. As you know, if we want to do this operation, let's use our wait key function here. So if I press 10 milliseconds, the ESC key, so why did I enter here 27? Because our ESC key ASCII value is equal to 27. That's why I entered 27 here. And also put a colon, and let's move inside of our if condition, and let's break our code. Alright, my dear friend, we are done. So now if we run our code, alright, we got an error now. So yes, this is about our serial communication because we didn't connect our Arduino to USB port of our computer. Let's comment our my Arduino variable, and if we run our code again, Alright, you see here we got the output like this, and also if I show my arm to the webcam, so let's look at this now. And you see here it looks perfect. So here is the result. And by the way, we can display our arm beautiful. So for this operation, for example, we can draw a line between our wrist point and also our elbow point, and the other hand we can draw a line again between our elbow and also our shoulder. So let's do this operation now. So now let's break our code. I will break my code now. For this operation, let's move inside of our result.poseLengthMarks condition again, and also move to the bottom of our condition. And as you know, if we want to draw a line using OpenCV module, we should use our line function in OpenCV module. So for this, let's call here cv2.line function and open and close parentheses. And as you know, we will enter 5 different parameters here. The first parameter will be our frame matrix that we want to display on the screen. So as you know, this is frame. And also the second parameter will be our first point. As you know, let's think about our arm. This is our wrist, this is our elbow, and let's think about this is our shoulder. If we want to draw a line between 2 points, for example this one and this one, we should use this one coordinates and also this one coordinates. For example, if it is x1 and y1 coordinate, the ending point will be our x2 and y2 coordinate. If we want to draw a line between this point and this point, and if this line coordinate is equal to x1 and y1, and also if you think about this is our starting point, this will be our x2 and y2 coordinate. So it's very simple. Let's do this operation now. As you know, if we want to draw a line between our wrist and elbow, these coordinates are x1, y1 and x2, y2 orderly. So for this, let's create a new tuple here and let's define our starting point as x1 and y1. And also the third parameter will be our ending point. As you know, the ending point is equal to our elbow's coordinate. So these are x2, y2. And also the fourth parameter will be our color. For example, let's draw a blue line. For this operation, let's create a new tuple and let's define as 255, 0, 0. And also the last parameter will be our thickness. For example, let the thickness value be value 2. And also let's copy our code again and let's move to a new line and let's paste it here, and let's draw a line between this time elbow and shoulder. As you know, this time our starting point is starting from x2, y2, and also our ending point is equal to x3, y3. Alright my dear friend, we are done. So now if we run our code, and also I will show my arm to the webcam, and you see here it looks perfect. So here is the result. So now let's continue. Yes my dear friend, in this lesson we have seen the arm detection. So now let's move on to our next lesson and complete our necessary mathematical calculations. Yes my dear friend, in this lesson we will calculate the distance between the shoulder and the wrist. For this, we will use the distance formula between 2 points. As you know, we used similar logic in our previous project. So now let's do this operation. As you know, if you want to do this operation, we need to get coordinates of our wrist and also our shoulder. because we will control our servo motor using this operation. So let's continue. Let's move to a new line and let's create a new variable here. Let the variable name be, for example, distance, and also put an equal sign. And if you want to calculate the distance between 2 points, what we have to do now is to do square root operation. So as you know, if you want to do this operation, we should use our math module. So let's call here math module. If you want to do square root operation, let's call our sqrt function, and also open and close parentheses. Now we have to subtract and square for the x and y coordinates. So what do I mean? Let's do this operation now. First, let's do exponential operation. For this, as you know, we should use POW function in our math module. So let's call here math.pow and also open and close parentheses. If you want to get power of any number, first we should write here which value that we want to get power of. As you know, let's start with our x coordinate. Our shoulder x coordinate is equal to x3, right? We should subtract x3 with x1 because we will calculate between our wrist coordinate and also shoulder coordinate. And also not limited to this, we will take the second power of this value. So let's put a comma and let's take the second power. And also we are done. So now let's move outside of our parentheses and let's addition our y coordinates. And also we will do exponential operation again. So let's call here math.pow and open and close parentheses, and then let's do this operation for our y coordinates. As you know, these are y3 minus y1. And also let's take the second power of this value again. So let's write here value 2. Alright my dear friend, we are done. So now, for example, let's print the distance value. If we run our code like this, so I will run my code. And you see here, we are getting the distance between our wrist and shoulder value. If I close my arm, and you see here, the distance value is decreasing, and otherwise the value is increasing. So here is the result. It's decreasing and also it's increasing. So we are done. So now let's continue. Yes, my dear friends, in this lesson we have calculated the distance necessary for us to control the servo motor. Now let's continue with our other lessons and send a signal to our Arduino board according to the value we have obtained. Yes, my dear friends, as you know, we performed the necessary calculation process in our previous lesson. Now we will send a signal to Arduino board according to the value we have obtained. When we open and close our arm, we get a value between 0 and 600. In general, a value between 0 and 250 represents closing our arm. The value between 250 and 450 allows us to close our arm halfway, and also 450 and above represents open arms. We will send a signal to our Arduino board according to these values. So let's get started. For this operation, let's move to the top and let's create a function. Let the function name be, for example, send signal to Arduino, and also we will tag a parameter here. The parameter will be our distance value, and also let's move inside of our function. Alright, so now we should create conditions here. These conditions will control the servo motor connected to our Arduino board. So let's create if condition here, and what did I say? if our distance value between 0 and 250, our arm is closing, right? So let's check this now. If our distance value between 0 and 250, let's move inside of our if condition and send a signal to our Arduino board. And by the way, let's delete this command. And also let's call here my Arduino variable. And as you know, if you want to send a signal to our Arduino board, what we have to do now is to call here our write method. So let's write here write, and also Arduino takes any data as a byte type, so that's why we should write here letter B here. And also let's create single quotes, and for example let's send a signal which is letter A. If we do something like this, our arm will closing using servo. And also let's continue. Let's do this operation closing our arm halfway. So as you know, for this let's create a new if condition here, and if our distance value between 250 and 450, let's move inside of this condition. So let's check. 250 is less than our distance value and also is less than our 450 value. Let's move inside of our if condition now, and this time for example let's send a signal as letter B, and we are done. And finally, if our distance value is greater than 450, let's move inside of this condition. So let's check. If the distance value is greater than 450, let's move inside of our condition and let's send a signal this time, for example letter C. So let's call here my Arduino.write, and let's send as byte type, and let's create single quotes and let's send letter C here. Alright my dear friends, we are done. Finally, we need to call our function. So for this operation, let's move inside of our if condition and let's move to the bottom and let's move to a new line and let's call our function. As you know, our function name is send signal. Alright, we write wrong here. Let's change as signal underscore to Arduino, and let's define our first parameter as our distance variable. Alright my dear friends, we are done. In general, our Python codes are like this. So what we need to do now is to write and test our Arduino codes. So now let's move on to our next lesson and complete our code by creating our Arduino codes. Yes my dear friends, in this lesson we will write the Arduino codes of our project. As you know, we have completed our Python codes, and by the way we want to use our Servo Motor. For this we need to include the Servo library. So let's do this operation now. Let's move to the top and let's include our servo.h library, and also let's move to a new line. Now we need to assign the incoming data to a variable. For this we need to create a variable of type char. So let's move to a new line and let's create a new variable as an char data type. And for example, let the variable name be incoming data and also put a semicolon. And then we need to create a servo object for defining pin and also controlling our servo motor. So let's move to a new line, and as you know, if you want to create a servo object, let's write here servo, and for example let the servo variable name be servo and also put a semicolon. So now let's come and define our servo pin. As you know, if you want to do this operation, we need to move inside of our setup function. So let's delete this command first. And also, if you want to do this operation first, let's call here our object. As you know, this is servo, and here we will use our attach method. Because with this method we will define our servo pin. As you know, our servo pin number is 9, so that's why I entered here value 9 in the parentheses and also put a semicolon. And of course, let's start the serial communication since we will communicate over the serial port. So for this, let's move to a new line and let's call here serial.begin. And as you know, we need to enter one parameter here, which is our baud rate speed. And when we complete our Python code, we defined our serial port baud rate speed as 9600. So let's define as 9600 here and put a semicolon. And finally, let's move to a new line. And now let's come and set the starting angle of our servo motor. As you know, we need to set it in full open, our arm, therefore we need to set it to 180 degrees. And also, if you want to control our servo motor, let's call here first our servo object and put a dot, and let's call our write method. And also open and close parentheses and put a semicolon, and let's move inside of our parentheses and let's define as angle 180. And if we compile like this our code, for example, let the file name be arm movements, and also let's save this file. And you see here the compiling is done. So now let's continue with our loop function. Now what we need to do is to control the signals coming to our Arduino board. As you know, we will control our servo motor according to these controls. For this process, first we need to check whether a signal is coming to our Arduino board. As you know, if you want to do this operation, let's move inside of our loop function and let's create if condition here, and let's check if any signal is coming to our Arduino board. So if you want to check this operation, let's call here serial dot available, and also open and close parentheses, and let's move inside of our if condition here. And then we need to check which data is coming to our Arduino board. As you know, we created here incoming data variable. And also we need to read which data is coming to our Arduino board, and also we will assign our incoming data to our incoming data variable. So for this, let's call here our incoming data variable and put an equal sign. And also if you want to learn which data is coming to our Arduino board, so let's call here serial.read function and also put a semicolon. Alright my dear friend, we are done. So now if we verify our code, and you see here we didn't get any error. As you know, our arm will have 3 different movements. It will perform these movements according to the incoming A, B and C signals. For example, if the A signal is coming, we will define our servo motor to 45 degree. That is, it will be completely closed. So let's do this operation now. If our incoming data is equal to letter A, and also letter A will be capital, let's control our servo motor angle is 45. So for this, let's call here servo.write and let's define as 45 and put a semicolon. As if our incoming data is equal to big letter B, let's control servo motor degree as 90 because this is half closed. And finally, our incoming data is equal to big capital letter C. Let's control our servo motor degree as 180, and also it's representing our arm is opened. So that's why we defined as 180. Alright my dear friend, we are done. Our Arduino codes are generally like this. Let's load our code now. First, let's verify our code. And you see here we didn't get any error, and if we upload our code to the Arduino board, and you see here we have successfully uploaded our code. Alright, so now let's open our Python codes. And here is our Python codes, and let's run our code now. Yes, my dear friends, as you can see, when we test our project, we encounter the result exactly as we want. When my arm is open, it's fully open. When closed, it's fully closed. And when it is half open, it's half open. Alright, my dear friend, this lesson is up to here, so now let's continue.